According to National Electrical Code Article 250.56b2, the ground electrode conductor, often abbreviated as GEC, must be connected to the metal water pipe before the first voltage joint used for the domestic water supply. This requirement ensures effective grounding and bonding of the electrical system to the earth, providing a lower impedance path for fault currents. Now, addressing the challenge of finding 6-inch ground clamps that can accommodate a 3/0 wire, it is true that such clamps are not commonly available. However, there's a practical alternative to achieve the required connection. This involves utilizing multiple smaller ground clamps to effectively bond the 3/0 wire to the 6-inch water pipe. One approach involves the installation of multiple 3-inch or 4-inch ground clamps equipped with screw terminals around the 6-inch pipe, ensuring they are spaced evenly. These clamps effectively distribute the connection points, providing a secure and reliable bond. Next, connect one end of each ground clamp to the 3/0 wire. This can be achieved using split bolt connectors or parallel groove clamps. These connectors are designed to create a strong and electrically sound connection between the ground clamp conductors and the 3/0 wire, ensuring a low resistance path for fault currents. Secure the other end of each ground clamp to the 6-inch pipe using bolts that are adequately sized to penetrate the pipe wall and engage the threads. The bolts provide a mechanical connection between the ground clamps and the water pipe, ensuring that the electrical connection is maintained even under stress or vibration. When selecting ground clamps and bolts, it's essential to ensure that they are rated for the appropriate conductor size and pipe material. This ensures that the connection can withstand the expected electrical and mechanical stresses without failing or corroding. Before installing the ground clamps, thoroughly remove any paint or corrosion from the pipe surface where the clamps will be installed. Paint and corrosion can act as insulators, impeding the flow of electricity and compromising the effectiveness of the grounding connection. Bare metal provides the best contact for a reliable electrical connection. To prevent corrosion over time, use stainless steel or brass ground clamps. These materials are resistant to corrosion in most environments and will help ensure that the grounding connection remains effective for the lifespan of the electrical system. To facilitate future reference and maintenance, clearly label the GEC and its connections. This helps ensure that the grounding system can be easily identified and inspected, reducing the risk of accidental damage or modification. Furthermore, consider the following points for a robust ground electrode conductor connection to a metallic water pipe. Firstly, ensure compliance with local codes and regulations. Electrical codes and regulations can vary by location, so it's essential to ensure that the grounding installation complies with all applicable requirements. This may involve obtaining permits, inspections, and following specific installation procedures. Secondly, use appropriate tools and equipment. The installation of ground clamps and connectors requires the use of specialized tools and equipment such as torque wrenches, wire strippers, and crimping tools. Using the right tools ensures that the connections are made properly and that the grounding system functions as intended. Thirdly, inspect the water pipe for damage or deterioration. Before making any connections to the water pipe, inspect it for signs of damage or deterioration, such as cracks, leaks, or corrosion. If the pipe is damaged, it may need to be repaired or replaced before a grounding connection can be made. Fourthly, tighten connections properly. The connections between the ground clamps, connectors, and water pipe must be tightened properly to ensure a secure and reliable electrical connection. Use a torque wrench to tighten the connections to the manufacturer's specified torque value. Fifthly, protect the GEC from physical damage. The ground electrode conductor should be protected from physical damage such as impact, abrasion, or exposure to chemicals. This can be achieved by routing the conductor in a protected conduit or raceway. Sixthly, maintain separation from other utilities. The ground electrode conductor should be kept separate from other utilities, such as gas pipes, water pipes, and communication cables. This helps prevent accidental contact and ensures that the grounding system functions independently. Seventhly, perform regular inspections and maintenance. The grounding system should be inspected and maintained regularly to ensure that it is functioning properly. This includes checking the connections for tightness and corrosion, inspecting the conductor for damage, and testing the grounding resistance. Eighthly, document the grounding system. Maintain accurate documentation of the grounding system, including the location of the ground electrode, the size and type of conductor, and the date of installation. This documentation can be helpful for future maintenance and troubleshooting. Ninthly, consider professional assistance. If unsure about any aspect of the grounding installation, consult with a qualified electrician or electrical engineer. They can provide guidance and ensure that the grounding system is installed safely and effectively. Tenthly, understand the purpose of grounding. Grounding provides a low impedance path for fault currents to return to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazards. 11thly, choose the right size conductor. The size of the ground electrode conductor must be selected based on the size of the service entrance conductors, in accordance with the National Electrical Code Table 250.66. 12thly, ensure continuous connection. The ground electrode conductor must be continuous, without any splices or joints from the service equipment to the grounding electrode. 13thly, avoid using water pipe as the sole grounding electrode. While a metal water pipe can be used as part of the grounding system, it should not be the sole grounding electrode. An additional grounding electrode, such as a ground rod or ground ring, should also be installed. 14thly, consider using exothermic welding. Exothermic welding is a process that creates a permanent molecular bond between two metal conductors. This can be used to create a very reliable and low resistance connection between the ground electrode conductor and the grounding electrode. 15thly, protect against corrosion. Corrosion can degrade the grounding connection over time, so it is important to protect the connection against corrosion. This can be done by using corrosion-resistant materials such as stainless steel or copper, and by applying a corrosion inhibitor. 16thly, use appropriate fittings and connectors. Use only fittings and connectors that are listed and labeled for use with a specific type of conductor and grounding electrode being used. 17thly, ensure proper bonding. All metal parts that are likely to become energized should be bonded together to create a low impedance path for fault currents. This includes metal water pipes, gas pipes, and metal enclosures. 18thly, test the grounding system. After the grounding system is installed, it should be tested to ensure that it is functioning properly. This can be done by measuring the grounding resistance using a ground resistance tester. 19thly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing grounding equipment. This will help ensure that the equipment is installed correctly and that it functions as intended. 20thly, be aware of potential hazards. Working with electricity can be hazardous, so it is important to be aware of the potential hazards and to take precautions to protect yourself. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing the circuit before working on it. 21st, verify the integrity of the water pipe. Before using a metal water pipe as a grounding electrode, verify that it is electrically continuous and that it is in direct contact with the earth for at least 10 feet. 22nd, consider using a supplemental electrode. If the water pipe does not meet the requirements for a grounding electrode, a supplemental electrode, such as a ground rod or ground plate, must be installed. 23rd, protect the grounding electrode from damage. The grounding electrode should be protected from physical damage, such as being struck by a vehicle or being buried under construction debris. 24th, maintain accessibility. The grounding electrode should be accessible for inspection and maintenance. 25th, document the location of the grounding electrode. The location of the grounding electrode should be documented in the electrical panel and on the building's electrical plans. 26th, use a grounding bushing or hub. When connecting a ground electrode conductor to a metal enclosure, use a grounding bushing or hub to ensure secure and reliable connection. 27th, avoid creating ground loops. A ground loop can occur when there are multiple paths for ground current to flow, which can cause noise and interference in electronic equipment. To avoid creating ground loops, use a single point grounding system. 28th. Understand the difference between grounding and bonding. Grounding and bonding are both important aspects of electrical safety, but they serve different purposes. Grounding provides a path for fault current to return to the source, while bonding connects metal parts together to equalize their potential. 29th. Comply with the NEC requirements for sizing the bonding jumper. The bonding jumper must be sized in accordance with NEC Table 250.102 cone. 30th. Use a bonding jumper to bond metal water pipes. Metal water pipes that are likely to become energized must be bonded together using a bonding jumper. 31st. Use a bonding jumper to bond metal gas pipes. Metal gas pipes should not be used as grounding electrodes, but they must be bonded to the grounding system to prevent them from becoming energized. 32nd. Use a bonding jumper to bond metal structural steel. Metal structural steel that is likely to become energized must be bonded to the grounding system. 33rd. Use a bonding jumper to bond metal equipment racks. Metal equipment racks that are likely to become energized must be bonded to the grounding system. 34th. Use a bonding jumper to bond metal cable trays. Metal cable trays that are likely to become energized must be bonded to the grounding system. 35th. Use a bonding jumper to bond metal conduit. Metal conduit that is likely to become energized must be bonded to the grounding system. 36th. Use a bonding jumper to bond metal enclosures. Metal enclosures that are likely to become energized must be bonded to the grounding system. 37th. Use a bonding jumper to bond metal raceways. Metal raceways that are likely to become energized must be bonded to the grounding system. 38th. Use a bonding jumper to bond metal panels. Metal panels that are likely to become energized must be bonded to the grounding system. 39th. Use a bonding jumper to bond metal doors. Metal doors that are likely to become energized must be bonded to the grounding system. 40th. Use a bonding jumper to bond metal frames. Metal frames that are likely to become energized must be bonded to the grounding system. 41st. Use a bonding jumper to bond metal supports. Metal supports that are likely to become energized must be bonded to the grounding system. 42nd. Use a bonding jumper to bond metal hangers. Metal hangers that are likely to become energized must be bonded to the grounding system. 43rd. Use a bonding jumper to bond metal clamps. Metal clamps that are likely to become energized must be bonded to the grounding system. 44th. Use a bonding jumper to bond metal straps. Metal straps that are likely to become energized must be bonded to the grounding system. 45th. Use a bonding jumper to bond metal brackets. Metal brackets that are likely to become energized must be bonded to the grounding system. 46th. Use a bonding jumper to bond metal screws. Metal screws that are likely to become energized must be bonded to the grounding system. 47th. Use a bonding jumper to bond metal bolts. Metal bolts that are likely to become energized must be bonded to the grounding system. 48th. Use a bonding jumper to bond metal washers. Metal washers that are likely to become energized must be bonded to the grounding system. 49th. Use a bonding jumper to bond metal nuts. Metal nuts that are likely to become energized must be bonded to the grounding system. 50th. Use a bonding jumper to bond metal lock washers. Metal lock washers that are likely to become energized must be bonded to the grounding system. By following these guidelines, electrical professionals can ensure that ground electrode conductor connections to metal water pipes are made safely and effectively, providing reliable grounding for electrical systems and protecting people from electrical shock hazards.